All right, calculus folks, we're continuing with derivative rules. We've already done all the basic rules for all the different kinds of functions. We did the product rule. Now we're going to do the quotient rule. Now, just a reminder, a quotient is a fraction. And so basically, this is going to be a derivative rule for when you're dealing with a rational function, okay, or something like that. So let's say that we have y is equal to f of x divided by g of x. So basically, this is a situation where you have a certain kind of function in the numerator and then another function in the denominator. Now, these can be polynomial over polynomial. You can have an exponential in the numerator and a trigonometric in the denominator. It doesn't really matter if you follow this rule, okay? If you follow the rule, then you'll always get the derivative right, okay? All right, so now an example of this would be, for example, if we had y is equal to, let's say that we have sine of x over, let's say, 3x to the fourth minus 2x to the third. All right, let's say that this is our quotient, okay? So we have a trig function in the numerator, and we have a polynomial function in the denominator, and we're going to find the derivative. Now, before we do that, I want to show you how I think of it inside my head, and you can think of it that way if you want to, or you can think about it this way. This is how you're going to see it, probably something like this in a math textbook, okay? But in my head, me personally, this is the way it exists in my head. The function looks like this. I call it top over bottom. That's how I remember it. Top over bottom. I have a top function and I have a bottom function. And here's how the quotient rule goes. Well, first let me tell you how the quotient rule doesn't go. It is not the derivative of the top over the derivative of the bottom. That is not how the quotient rule works, okay? You're going to want to do it that way. If you can't remember the quotient rule, that's how you're going to want to do it, and you're going to be wrong. It's not what you think it is. So, the derivative, dy dx, is not, in this case, cosine of x over 12x to the third minus 6x squared. That is not the derivative of that, okay? We don't just do the derivative of the top over the derivative of the bottom. Even though that's what you want it to be, that's not what it is. So we're going to get rid of this. Well, what is the quotient rule? Well, it's a little bit like the product rule, but it's a little more complicated than the product rule. Here's how it goes. I'm going to say it first, then I'm going to write it down. It's the derivative of the top times the bottom, not change. The bottom is not, it's not the derivative of the bottom, it's just the bottom. So it's the derivative of the top times the bottom minus the top times the derivative of the bottom all over, so that's a numerator, that whole thing is a numerator, all over the bottom squared. Let me write it down. I'll say it again and I'm going to write it down. So the derivative here, y prime, is going to be the derivative of the top, top prime, times the bottom, minus the top times the derivative of the bottom, or bottom prime, all over, and I put the bottom in parentheses, all over the bottom squared. That is the quotient rule, all right? Let me show you how it would look probably in a calculus textbook. You'll see dy dx, or y prime, is equal to the derivative of the top, which is f prime of x, times the bottom, g of x, minus the top, f of x, times the derivative of the bottom, g prime of x, all over the bottom, g of x, squared. Now, I want to warn you, sometimes in your calculus textbook, they might switch these around. They might say instead the bottom times the derivative of the top minus the derivative of the bottom times the top over the bottom squared. But look, multiplication is commutative, so it's okay for these to be switched around. It's not okay for these to be switched around. This has to be on this side because subtraction is not commutative, right? Okay, so that is the quotient rule. So now let's see if we can find the derivative of this one right here. Let's see, dy dx is going to be the derivative of the top. What's the derivative of sine of x? That's cosine of x. Cosine of x times the bottom, unchanged. Now watch this. This is a binomial. I need to put it in parentheses. So times the bottom. The whole bottom is 3x to the fourth minus 2x to the third. Okay? Minus the top, unchanged, that's sine of x, times the derivative of the bottom. Well, the derivative of this is still going to be a binomial, so I'm going to put that in parentheses. The derivative of 3x to the fourth is 12x to the third minus the derivative of 2x to the third is 6x squared. Close the parenthesis. There we go. Some nice parentheses there. Now I'm going to all over the bottom squared. I'm just going to take this and square it. I'm not actually going to work it out. I'm not going to expand it. I could, but there's really no need to. I'm just going to put this 3x to the fourth minus 2x to the third. I'm just going to put that and then put a squared on the outside. And this messy thing, that's my derivative. That is the derivative of this quotient. Is it messy looking? It sure is. However, it is the derivative. And usually, in most cases, professors or teachers, they're okay with you just leaving it like this. There are certain cases in which they would probably want you to simplify something, but I'm okay with that. You know, it's bad enough, it's messy enough, why spend any extra time on it? Okay, that is the quotient rule. Let's do one more example, shall we? All right, here's one. We've got f of x is equal to 4 to the x power over tangent of x. Okay, so our derivative, f prime of x, is going to be equal to the derivative of the top, which is 4 to the x power times the natural log of 4 times the bottom, tangent of x, times tangent of x, minus the top, 4 to the x power, times the derivative of the bottom, which is secant squared of x. I better know all my derivative rules, right? Better know my derivatives of trig functions rules. All over the bottom squared. Tangent of x squared. Tangent of x times tangent of x, which is tangent squared of x. All over tangent squared of x. And here's my derivative. Now, in some cases, see, this is great. When you have something like this, you can actually factor things out of it. Like, for example, the only thing you can really factor out here is you can factor out a 4 to the x power. And sometimes when you're able to factor things out, you can do identities and you can manipulate it, or you can use substitution or something. You can do all kinds of fun stuff. So that's why, but before you can do any of that fancy stuff, you have to know your derivative rules. You have to know that the derivative of a quotient is the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. Okay? That is the quotient rule. Now we're going to move on to the chain rule.